Okay. All right. So, but we'll know to look for the catcher now. So Andy tried catcher when he did Little League a couple years ago, and he played machine pitch and got hit a few times. Poor kid. He toughed it out and stayed being catcher, but it was rough. Okay. So determine two coterminal angles in radian measure, one positive and one negative for each angle. So hopefully we have got gathered from the notes that you hopefully took on Friday. When we are in what we call radians, we go one full revolution around that unit circle, and one full revolution around the circle is 2 pi. We're also going to talk today about it in degrees, which is 360. Okay, so I do the radians first, then I pull you back to degrees, just to make sure we've covered it. So to be coterminal, it means that whatever angle you have in here lands on itself. So it goes around a revolution and lands back on itself. And it could go around multiple times. Okay, so that's what coterminal means. So either I can add or subtract 2 pi to get the coterminal angles. So let's talk about really quickly 2, okay, or 2 pi. If I am in over 6 world, is what I like to call it, okay? All I'm doing is scaling up the fractions. So if I'm in over 6 world, I would be adding and subtracting 12 pi, okay, right? Because I multiply both of them by 6, okay? If I am in over 3 world, I would be adding and subtracting, I would be adding and subtracting and multiply both by 3, 6 pi over 3, all right? If I am in over 4 world, so I need your help, okay? Hopefully you figured out what I'm doing here. If I am in over 4 world, what's going to be my numerator? Can you guys tell me what the numerator is on that one? I want to make sure you're paying attention. Good. And the good news is the majority of the time, these are the fractions we use. Okay, so we don't have to know our equivalent fractions, but not much beyond this. Okay, there is one other one. It doesn't come up as much. We can work in over 2 worlds, which would be 4 pi over 2. Okay, so every time we do one of these, we're either going to add or subtract 2 pi. I have to decide which world I'm working in. Okay, so in A, I am in over 6 world. So I'm going to add 12 pi over 6, which would give me 13 pi over 6. But it says that I have to have one positive and one negative angle, okay? So I'm also going to take pi over 6 and I'm going to subtract 12 pi over 6, which means that that is negative 11 pi over 6. Okay, so that will get me one positive and one negative. My favorite thing to do on your test, though, okay, is to do it more than one time. So I could add 2 pi or 12 pi over 6 again to that one, and I would get like 25 pi over 6 would be another coterminal angle. Okay, I could subtract more as well. All right. All right, so I'm going to add, looking at B, I'm going to add 8 pi over 4. Pi plus 8 pi is 17 pi over 4. And then I'm going to subtract 8 pi over 4, but I did not get to a negative angle, and I need one of them to be negative. So I'm going to go from pi over 4, and I'm going to subtract another 8 pi over 4, and I would get negative 7 pi over 4. So I could use this one as my negative. I use either one positive correct answer. Okay. All right, I'm going to do a little checking for understanding. You ready? Okay, so what do I need to add to 5 pi over 3 to start looking for my coterminal angles? Can you guys tell me in the chat? And you can, pi can be pi. Tell me in the chat. I'm looking in this emoji keyboard thing I found. I don't know if pi is in here. I don't see it. All right, we're good with the 6 pi. Excellent work, everybody. Make sure you're paying attention and helping out. So I'm going to start by adding 6 pi over 3, which would be pi over 3. And then I have to get a -1, so I'm going to subtract 6 pi over 3, which would be -11 pi over 3. Okay. All right, we got to talk about complement and supplement. I know you know what these mean, okay? What do complementary angles have to add up to? Think about degree world. What do complementary angles have to add up to? Can you tell me in the chat? Anybody remember? What about, okay, we know something. It's not complementary that you're giving me, but we got something down in the chat. That's good. All right. We are looking, you guys gave me supplementary. There we go. Now I've got some complementary going. All right, so it had to be one of the two, right? It's always one of the two, complementary and supplementary. So up to 90 degrees, or in our radian world, they have to add to pi over 2, okay? And then supplementary have to add up to 180 or pi. And we're going to learn how to convert today, so we're going to get to that piece. All right, so everybody, hopefully we get that written down. Give me just a second. I want to make sure I am doing this the right way. This is acting silly. Okay, so in order to find the complement or the supplement of each angle, okay, did I do this at this class? It doesn't look like I did. I just did the conversions. Okay, all right. We are going to basically have to figure out what adds up to 90. So in this case, of course, I used over 5 world instead of over 10 or over our 3, 6, or 4 world, huh? So I'm going to start with what would pi over 2 look like if I had to make it over 5. That would be, sorry, I'm thinking through it. Let's try pi first. So if I wanted it to be pi, I know I have to make the denominator 5. So it would be 5 pi over 5. So if I'm going to get supplementary, I'm going to subtract from that. So I would have to do 5 pi over 5 minus 2 pi over 5 would give me 3 pi over 5. That would be the supplementary angle, okay? All right, to do complementary, I know I have to take pi over 2 and I have to subtract 2 pi over 5. Well, unfortunately, they don't have common denominators, right? So I have to get a common denominator. What common denominator am I going to use? Can you guys tell me that in the chat? What common denominator should I use on this? What do you think? I have 2 and 5. What's my common denominator? All right, nice work. We got to use 10. Perfect. All right, so to get to 10, I have to multiply this one by 5, so I'd get 5 pi over 10, and I have to multiply this one by 2, so I get 4 pi over 10. So this one, my complementary angle would be pi over 10. Okay, let's try that one more time. Okay, so supplementary, let's do on the 4 pi over 5. So supplementary again, it's really like saying pi minus 4 pi over 5. Or in this case, our common denominator would be 5, and we use 5 pi over 5 minus 4 pi over 5 would just be pi over 5 would be the supplement. For complementary, okay, I am going to subtract pi over 2 minus 4 pi over 5. And again, we would get our common denominator of 10. So the first one I multiply by 5. The second one I would multiply by 2. And it's okay, we are going to end up with a negative complementary angle, and that's all right. So negative 3 pi over 10. I'll give you a minute to catch that up there. All right, so another way to measure angles, so we've actually only ever looked in the other way. We're starting to learn about the radians way. So another way to measure angles is in degrees of a circle, and we know that there's 360 degrees in one circle, okay? If we look at the quadrants, okay, this goes 0 degrees, we know this is 90 degrees, we know this is 180, we know this is 270, and then this one is 360, and it could keep going. And again, this is quadrant 1, 2, 3, and 4. We name them with Roman numerals. The way I remember it starts in quadrant 1 there, and it makes kind of a letter C when you go counterclockwise. So 274, if I think about what quadrant 274 is in, it's got to be between 270 and 360, so it's in quadrant 4. This is a 180, so you know I can read that 180. Okay, so what do you guys think that 153.4 degrees, what quadrant is that in? Can you tell me in the chat? What do you guys think? What quadrant is it in? All right, excellent work. That is in fact in quadrant 2, okay? The next thing we're supposed to do is we're supposed to sketch the angle in standard position, okay? So you don't have to be perfect. It has to be an estimate. I believe on the homework, these ones are multiple choice, okay? So I know that 90 is here, okay? I know that 180 is here. So I know I have to be somewhere between 90 and 180. So 120 is going to be in here somewhere. That's my terminal side. I really should draw my initial side right there. And then I will put an arc in it and then label it with whatever the degree measure is. So I'm approximate. I know I've got to land in quadrant 2. All right, negative 220 is a little bit trickier, okay? Negative means I go down first rather than up when I count my angle, okay? Because I'm going to go in the clockwise direction versus the counterclockwise direction. Or I'm down, right? Negative seems to be, means down, right? So I know that this would be like negative 90. This would be negative 180, negative 270, negative 360, and so on, right? Starts at 0. So I need to get to negative 220. So I'm curious what you guys think. What quadrant do you think that this should land in if I'm going in these negatives? If I have to be at negative 220, which quadrant do you think I need to land in? 1, 2, 3, or 4? What do you guys think? All right, you guys are getting it. Good job. It is quadrant 2. And again, I don't know, it's probably going to be, it's going to be almost right in the middle, huh? I'm going to go there. But then when I draw this angle, okay, I have to draw it in the other direction. That's why I do the arcs. I'm going to draw my arc here, and then I'm going to label it negative 220 degrees. Give you a minute to get there. Make sure you're caught up with me. Okay. Let's take a look at number 7 here. So we need to determine 2 coterminal angles in degree measure, one positive and one negative. So instead of adding and subtracting 2 pi, I am going to add and subtract 360. Okay, so I'm going to do 45 plus 360 and 45 minus 360. So I'm pulling out my handy dandy calculator because it's Monday morning and I'm not going to add those together correctly. All right, so I'm getting 405 for this one, labeled in degrees. And this one I got negative 315 degrees. So literally add and subtract. Now, sometimes if I were to add 360 to 420, I get like 780, okay? If I start subtracting, I'm still going to get a positive one. So sometimes I just subtract. It just depends on how big the angle is to begin with. So I'm going to go 420 minus 360. And let's see, I get 60. So technically that could be my positive angle, even though the other one, when I added 360, is also a correct answer. There's lots of correct answers. In order to get my next one, I'm going to have to subtract again. So that's going to give me negative 300 degrees. Okay. Help me out in the chat. What do I need to do to see here to the negative 135 to get a positive coterminal angle? Can you put that in the chat for me? How am I going to get a positive coterminal angle? All right, I like that everybody's saying add. I like specifically everybody who said add 360. I really appreciate that because we got to make sure you understand how much you are adding, okay? So thank you for everybody who said add 360. All right, so when we add 360, I got 225. All right, how do I get another negative coterminal angle? Can you tell me that in the chat? How do I get another negative coterminal angle? I like how we're being specific this time. Very nice. Thank you for making the change. I appreciate it. I want to make sure you're understanding that chunk of it. Okay, good job, everybody. So negative 135 minus 360. Okay, let's see. Negative 495. Okay. So you all just told me, let's see, that was that one. Of course, this one doesn't have all the answers in it. At least it has that. I was just looking for an old version of these notes for definitions. All right, so find the complement and supplement of each angle. So complement and supplement, again, you just told me means 90 and 180, right? The way I remember that is 90 comes before 180 and complement comes before supplement in the alphabet, okay? So the complement, I am going to go 90 minus 85, which I should have probably put complement out there, which would give me 5 degrees for the complement. For the supplement, we're going to go 180 minus 85. So would it be 95 degrees? Double check my arithmetic. I did it without the calculator. Trying to be brave and do it in my head. 180 minus 85, 95. Perfect. Okay. All right. The next thing I am going to show you, I'm showing it to you because this is this is the time to show it to you. We don't use it a whole lot, but if you ever run across it or I accidentally assign a problem that has it in it, then you know and understand what it means. Unfortunately, Desmos does not handle this very well at all, okay? It is terrible at handling it. It doesn't really do it. So if we were at school and we had our graphing calculators and could pull out our TI graphing calculators, or even our little scientific calculators, they work. I don't think it works on the phone scientific calculator, okay? Maybe, I haven't played with it. So I found a website that will do the conversion for us, but you just need to understand what it is, okay? So what this is it's a more specific way to measure an angle, and it's called degrees, minutes, seconds. Okay, it looks like this little funky thing here. Okay, degrees, and then the little hash the one hash means minutes, and the two means seconds. Okay, and it's just a more precise measure of your angle. Okay, it's like it's like another way to write a decimal point. Okay. So 1 minute is equal to 1/60th of 1 degree. So it's like taking that degree and dividing it into 60. Okay. 1 second is like taking the degree and dividing it by 3,600, or it's 1/3600th of a degree. That's a 30. I can barely read it. I'm sorry. Let me try a different color. 3,600. There we go. Okay, so we are going to completely use a calculator to do this. I'm not going to do any kind of crazy, let's figure out all the arithmetic stuff, because I just need you, if you run across it, I accidentally assigned a trig problem that has degrees, minutes, seconds, you will be able to do it. So I'm going to come over to my degrees, minutes, seconds calculator here. Apparently, oh, there it is. Okay. And we're going to put this in. Okay, so I gave you this link in Google Classroom. Okay, I will put it. Oh, I don't have it in there. Oh yeah, I can put it in the chat. I have the mute going on this one. I'll put it in the chat too for you. Okay. Okay, so there it is in the chat. There's probably others. This is I found a couple and I decided this is the one I liked the best. So literally all I do is I'm going to type in the degrees, which is 64. And I'm going to type in the minutes, which is 32. And I'm going to type in the seconds, which is 47. And then I'm going to hit convert, and it will give me decimal degrees. So I would write down 64.546. Okay, because we're going to go three decimal places. So 64.546 degrees. Okay. All right, let's try it again with the 25. Okay. All right, so I'm going to just hit reset, and then I'm going to go to 25. So it's going to be 25, and then minutes is going to be 13, and seconds is going to be 45. And then I just hit the button that says convert, and it tells me I've got 25.229. And that's in complete degrees. All right, next it wants me to go backwards. So now it's saying take that decimal degrees and turn it back into degrees, minutes, seconds. So I'm going to use that same calculator. Okay, so I'm going back to this same calculator here. And do you see how it says swap? So I'm going to hit swap conversion. And now it wants the decimal degrees, and it's going to tell it to me in degrees, minutes, seconds. Okay, so it's 45.126. And I'm going to hit convert. And then the final degrees, minutes, seconds is here. So 45 degrees, 7 minutes, 33.6 seconds. So we would write down 45 degrees, 7 minutes, 33.6 seconds. That's really all there is to it. We want like 700 of those on the next test, right? Because you just have to hit a button in the calculator. It won't happen, but we can wish. Maybe I'll give you one. Okay. All right. It'd be a good, nice, easy problem, right? We always want an easy problem. Okay, I'm gonna hit reset. Okay, so we've got the next one. Let's see if it does a negative. I didn't try it out with a negative. So negative 157.345. I'm gonna hit convert. Oh, it did do it. Negative 157, 20 minutes and 42 seconds. So negative 157 degrees, 20 minutes, 42 seconds. And if you do have a scientific calculator at home, you are welcome to use that. You're going to look for the button that says DMS, and it's probably got like a little arrow on it. It's been a long time since I've looked at the scientifics at school, so I don't remember exactly where it is and what it looks like, but I know that that's the button, if you can find that. All right, here's the big, what we really have to get done this lesson. By the way, we're going to get rid of 19 and 20, so we're only going to go up to 18. So we're almost done with extra time to spare today. We'll see. We'll see if we've got extra time to spare here in a minute. Okay, so to convert from radians to degrees and degrees to radians, so we have to be able to have a conversion between the two, all right? So when you are in radians, you should have a pi in the answer. When you are in degrees, no pi, okay? That's why we like math. In math, we like pi better because pi is delicious, right? Radians better because pi is delicious. All right, so we're going to convert to degrees to radians. So that means we multiply the degrees by pi over 180. Because I want to put radians back in, so I need pi in the numerator, okay? To convert from radians to degrees, we multiply by 180 divided by pi. And notice it says, do not use calculator on any of these. So I would expect no decimal points on this. If you're using a calculator to help you simplify your arithmetic, that's fine, okay? But I should not see, I should see some work on these, no decimal point answers, okay? Just gonna see if this version has the whole lesson. It does, cool. All right, so let's take a look at 13. So I want to take 13 and I want to add I want to convert it to radians, so I'm going to put the pi in. So pi over 180. And then I'm going to simplify my fraction, okay? I haven't heard from you all in a while, so what number can I divide both 135 and 180 by? Can you help me out with that? What can I divide both 135 and 180 by? I want to make sure you're still paying attention. And that's an easy one, right? We all can do that. Awesome, awesome, awesome. Perfect. Okay, so we're going to divide by 5. When I divide 135 by 5, I think I get 27. And 180, I get 36. So that means I have 27 pi over 36. But wait, can't I divide both of those by something too? Doesn't 3 go into both of them? 3 goes into 27 9 times and into 36. Why did I write 4? Oh, well, I can do better. I can do 9, can't I? Let's do 9. 9 goes into 27 3 times and 36 9, or what am I doing? 4 times. So 3 pi over 4. All right, let's see if we got it. Okay. So if I want to take it from degrees to radians, what do I need to multiply 540 by? You tell me in the chat, what do I need to multiply 540 by? My contacts are not working today. All right. Pi over 180. Good job. Okay. So pi divided by 180. All right. And this one, look at how nice this one is. Look, the zeros go away. So I get 54 over 18 pi. But I believe I can still divide that, right? I think that I can divide by 9 again. So 9 goes into 54 6 times and into 18 twice. So, oh, check that out. So now I've got 6 pi over 2. That reduces to 3 pi. All right, we're going to do it again in -270. Actually, take a minute and do 270 on your own. Try 270. See if you can get it reduced. I'll be quiet for a minute since we've got some time. Try 270.